Alrighty, we're going to talk about the things you're going to have at the SOL. You're going to have a formula sheet. Ask for a paper copy and write on it. Don't feel bad about that. Also use your scratch paper, especially the graph paper they give you, so you can plot points, count slope, do transformations, those types of things. When taking the SOL, you want to write down as many things as possible so you can check yourself and not make mistakes. You also want to double check with Desmos on everything you do. The first thing I would do with my formula sheet, if I were you, is I would mark on it a little bit. So let me show you what I would do. I would start here, come down and around, and over the top. The formulas in that red circle are flat figures, like flat shapes, a triangle, a square, a rectangle, a circle, a parallelogram, and a trapezoid. First things first, we do not use the square formulas because the rectangle formulas work just as well. The other thing is that this perimeter formula for rectangle, I wouldn't use it. I would just add all four sides. That's the easiest way to find the perimeter of a square or a rectangle. But let's talk about each one individually, because you never want to mistake a formula for a different shape. So the triangle, the formula is right underneath it. It starts with an A. A means area. So if you look at the formula, it's 1/2 BH. If you look at the picture, it will show you exactly where to find the B and the H. So that way you don't make mistakes. Same with the area of a rectangle. The area of a rectangle, length times width, shows you the length and the width. Then we have the circle. We do not use this middle formula here. We use the one above it. Circumference, which is the C, circumference, and I'm even going to write it here, equals perimeter of a circle. Okay? So if you want to know the perimeter all the way around a circle, you would use 2 pi r. In a little bit, I'm going to show you what you would do if you want the perimeter of a semicircle. If you want the area of an entire circle, it's pi r squared. Now, I'm going to do my best to draw a semicircle. I'm not sure if I can do it or not, but I'm going to try. All right, let's pretend that that is a semicircle. I know it's not a good one, but I tried. So I'm going to label it semicircle. If you're dealing with semicircles, which is half a circle, your formulas change slightly. Your circumference or your perimeter of that semicircle would be 1/2 times 2 pi r. If you wanted the area of a semicircle, it would be 1/2 pi r squared. So you just have to remember, if you're dealing with half a circle, use the circle formulas with a 1/2 in front of it. Okay? Then you go down to the next line, the second row, and you see the parallelogram. Again, BH is the area of that parallelogram. It tells you that the B's are the same. You only have to use it one time, and the height is the line that touches those bases. All right, and again, perimeter, you add the 4 sides. Perimeter for a triangle, you add 3 sides. Now, if you want to look at a trapezoid, if you want the perimeter, you add the 4 outsides. Okay, if you want the area, the formula is right there, 1/2 H, parentheses, you have to use parentheses, B1 plus B2, and B1 you type straight into your calculator, B1 equals. Then go to the next line, B2 equals. It does not matter which base you use for which one. The height is inside, touches both the bases, and has those right angles. Okay? So the next thing we're going to start looking at is our figures. Those are things you could actually pick up and throw across a room. Okay? The first one is called a rectangular prism. Volume is how much you fit inside, length, width, height. Surface area, SA, surface area, is what it would take to cover all of the outside faces, all right? And if you look at the picture, it shows you what length, width, and height are. Those three don't matter, just don't mix them up. You know, if you want a number to be length, just use it as length the whole time. Okay, same with width and height. The next thing we have there is a cylinder. Okay, so I'm actually going to write REC prism, rectangular prism there. Then this is a cylinder. Whoops, I did not spell that correctly, so I'm going to back up a little bit and just leave it as cylinder. SCYL. If you look at it, it shows you clearly what the height is. It's the side that touches both of the bases. On a cylinder, your bases are circles, so you'll need a radius. If you don't know what a radius is, look at the picture or look up at the circle, and it'll show you that if a line goes from one side clear to the other, it's a diameter. But if it goes halfway, it's a radius. Okay? So you want to make sure that you know the difference, again, between volume, how much it takes to fill that, and surface area, how much it would take to cover the outside with paint or with paper. All right? Alrighty, let's get this done. We talked about a rectangular prism, we talked about a cylinder, and now we're going to talk about a square-based pyramid. So I'm actually going to write that over to the side. Well, maybe I will. If I actually have a pen, I can do that for you. We're going to talk about a square-based pyramid. Okay. So when you have a square-based pyramid, it's important to remember again your keywords for volume. How much you can fill something with is going to be volume. And surface area is what you're going to need to go around the outside, whether that's with paint or paper or whatever it is. So in the formulas, if you'll notice, the volume is 1/3 big B times H. Well, big B is the area of your base. And if you look at the bottom of your whole formula sheet, this isn't the whole one, it actually tells you big B is the area of your base. Well, your base is a square. So your area of your base is always going to be very easy to find, and we'll show that to you in some examples. So say, for example, the base has a side of 5. The area of your base would be 5 times 5, or 25. Then you have H, which is the height. And if you look at the picture of your square-based pyramid, the H is the distance from the tippy top, drop straight down to the middle. Okay? Then you have your surface area, 1/2 LP plus big B. The L is your slant height. Again, look at the picture, and you will see that it's down the side. It kind of rolls down the side of the pyramid. The P is the perimeter of your base. Okay? The perimeter of your base is P, and that would be adding up all 4 sides. So again, like the previous example, if your side is 5, 5 plus 5 plus 5 plus 5 is 20. Or, since it's a square, you can do 5 times 4 is 20 for the perimeter of your base. All right? Then you have plus big B, same as in the volume formula, side times side gives you the area of your base. All right. The next thing we're going to look at is a cone, kind of like an ice cream cone, except this one's upside down, so it looks like a hat, maybe. You have a lot of the same pieces. The slant height, L, comes down that side. The height starts at the tip top, drops straight down to the center, and then from the center of that round base, that circle base, to the edge is the radius. So volume would be what it takes to fill that. If it's a ice cream cone, how much ice cream cone will fill it? If it was a party hat, how much popcorn would fit in there, or candy? So volume is 1/3 pi r squared h. Look at the picture. for the details. And then surface area is pi r squared plus pi r L. L is that slant height again. Finally, we have the P theorem, just in case you forget it, or just in case you forget where the legs are and where the hypotenuse is. Remember, your hypotenuse is always across from your right angle, and your legs are what form your right angle. And then pi, you never want to use any of this. You always want to use the pi key in your calculator, okay? So make sure you use your formula sheet, get a paper formula sheet, and use it to the best of your abilities. There's a lot of information on there that can really help you. Have a great day, guys. We'll talk to you soon. Bye-bye.